Okay, welcome to the Unit 2, Lesson 3. This is distance on a number line and also has the length of a line segment. Okay, we will also be talking about the distance formula. So let's see where this starts. First thing we're going to do is start with some definitions. And the first thing is that you need to recall that a line segment consists of two endpoints and all the in-between points on the line connecting them. Okay. Next we have that in this lesson we're going to be concerned with the length of the line segment, and that is simply the distance between the two endpoints. Okay, so if we have the line segment AB, then we're going to make that correspond to the number line, and the AB here are the coordinates, and so the absolute value of A minus B is the length of AB. Okay, notice that AB, without anything above it, now symbolizes the length of segment AB, while the AB with the line segment above it symbolizes the line segment itself. Okay, you need to differentiate between those. Okay, example 1. Use the points on this number line to find the line segment lengths in examples 1 through 6. Okay, so notice they've got several points here. We're going to find the distance between the pair that they identify in each example. So AB, the length of AB is 6.5 minus, or negative 6.5 minus negative 9. So we do that, and this is what we got. The length of AB is equal to negative 9 minus negative 6.5. That's the absolute value of that, so that keeps you from getting a negative number. So this gives us this right here. This is negative 9 plus 6.5, which gives us the absolute value of negative 2.5, which means that our line segment has a length of 2.5. Okay, next we have, for example 2, they want to know how far it is between G and D. Okay, so this time we take the coordinates of G and D, in this case 0 for D and 8 for G. So we're going to subtract 0 from 8, take the absolute value of that, so the length of GD is equal to the absolute value of 8, which is equal to 8. Okay, example 3, this time they want us to find the length of line segment FB. So from F to B, this is negative 6.5, this is positive 4. So we plug those into our formula, which says that you simply subtract them. So the absolute value of 4 minus negative 6.5 gives us 4 plus 6.5, which is 10.5. Make sure you take the absolute value. Once again, this keeps you from getting a negative value. Example 4, use the points on this number line to find the line segment again. So once again, this time we have C and E. Okay, notice this is 2.5, and this looks like about negative 4.5. So we subtract those, take the absolute value. In this case, it's going to be the absolute value of negative 4.5 minus 2.5. Gives us the absolute value of negative 7, which is 7. One point about geometry is that line segments never have a negative length. All right? So in this case, they want to, in example 5, they want to know what is the difference between the length of xy and segment xy. Okay? So the length of xy is the length of the line segment, and segment xy symbolizes the line segment itself. Okay, example 6, they want to know what is the length of FD. So F is here at 4, D is at 0. We take the difference of those. Once again, notice that this one has what? Line FD actually has no measurement that we can come up with because it's infinite in length, and then it goes from infinity to infinity. Okay, the distance formula, this works for things like on the Cartesian coordinates. On the line segment, or on the number line like we were working on with the previous ones, everything is very simple because it's a simple difference between the two coordinates. Once again, this time we're going to have the difference of two coordinates, but this one, because it works in 2 dimensions, has a lot in common with the Pythagorean theorem. In fact, that's where the distance formula comes from. So another word for things that are not on a number line is that they lie in a coordinate plane, and the endpoints are going to be x1, y1, x2, y2, and we get this for our formula, which is the distance is equal to the square root of x squared, or x sub 2 minus x sub 1 squared, plus y sub 2 minus y sub 1 squared. Okay? So this is the distance formula. You need to know it because if you need to know the length of 2 line segments in geometry, this is typically how you have to find it. Okay, so find the length of the line segment whose endpoints are 4, -2, and -8, 6. So we put this into our formula. So x1, y1 is equal to 4, -2. x2, y2 is equal to -8, 6. Okay, this is our distance formula. So we've rewritten it here. Now we're going to insert the values that we have over here. So x2 is -8. x1 is 4, so -8 minus 4, and that's in parentheses squared, plus 6 minus -2, all in parentheses squared. Okay, so this gives us -12 squared plus 8 squared is equal to 144 plus 64, and we're taking the square root of that. So this gives us the square root of 208. When we combine these two here, place that in our calculator, we get a length of approximately 14.4222. Okay, find the length of line segment AB. For example 8, this time they gave it to us on the coordinate system. Okay, so we have to find the coordinates of the endpoints. So what we find here, if we look this up, or if we count these over, we get 1, 2, 3, 4, 5, 6, and this 7 looks like it's disappeared here. But this is on -7 for the x. -3 is -1, -2, -3. So that's what our y coordinates are. Our b coordinates, we count those up, and we got 7, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so that's our coordinates. So we're going to plug it into the distance formula. This time we just changed it a little bit. This, instead of saying x2, this is saying the x from A minus the x from B plus the y from A minus the y from B. Okay, this works just as well, or you can write above this x1, y1, x2, y2 if you prefer to do it that way. Okay, so this gives us the square root of -7 minus 7 parentheses squared plus -3 minus 7 in parentheses squared. This gives us -14 squared plus -10 squared. So we take the square root of 196, which is 14 squared, plus 10 squared is 100. So this gives us a net effect of the square root of 296, which is approximately 17.20465. Okay, sorry I didn't give you quite enough time to get it, but here it is back. So hopefully this will give you time to pause it and get your notes down. If you have any questions, be sure you come in tomorrow, write them down on the post-it notes, and put them on the parking lot, and we will get the questions answered before we start at work. Thank you. Goodbye.